we're going to find the area of this parallelogram. We're going to be using the squares or the grid paper to help us understand how measurements are found, or when they give you a measurement, what does it really mean on a figure. Most of the time they give you the measurements and you're not able to see what it means because they just give you the numbers. So in this case, what we're going to be doing, we're going to be using this ruler here to help us see what the measurements are. So here, I mean, you can count the squares, but I use the ruler to help you see it better. So that measurement right there is 12. Let's look on the top. That one is 12 also, 12 units. The slanted side, it's about 11 and a half. The second slanted side, it's about another 11 and a half. Second slanted side is also about 11 and a half. So if we measure, this is a base, so we measure from the base all the way to the top, you can say is 7. But look what happens if you bring the ruler a little closer. The measurement doesn't change as long as you keep it from the base all the way to the top, to how tall it is, to the height. Notice the height doesn't change. One of the things you want to keep in mind is that in order to measure it, you got to keep the 90 degrees angles, which is right here, like this little square, and that is where you measure the height. So you might have the height in a corner, you might have it towards the end. You know that the measurement will be exactly the same. So the height for this parallelogram is 7 units. Now let's record our units. For the base we said it was 12, and let's just use feet, just to get used to having the units there. That's 12 feet. We said this slanted side was 11.5 feet, and when we measure the height, we found out that the height was 7, and we're going to use feet. Part 2 is using the information that we have to find the area of the parallelogram using mathematical symbols or the formula, and how that can be understood better using the grid paper or using the squares inside the figure. And what we're going to do is we're going to try to decompose the figure and see if we can find out how we can find the area using the information that we know about rectangles. So if you notice, there's one rectangle right there. I'm going to highlight it so you can see that. And what I am going to do now, I am going to just copy this triangle. Okay, so we have that. I'm going to put it right here. Once again, cut or copy that rectangle next to the rectangle, that one right there, and I'm going to bring it down here. How about if we label this one to be A, so this is your A, and if we label this one to be B, and that's your B. And when you put them together, you're going to see what happens. Do you see they're still united by the same height, right? And I am going to bring the other rectangle around here, right there. But if I bring this up here, look what happens. You get a rectangle. So what do you notice at this point? At this point, you should have noticed that the base of your parallelogram is the same thing as your length of a rectangle. That the height of your parallelogram is the same thing as the width of your rectangle. But since we're talking about a parallelogram, in a parallelogram, we use the formula area equals the base times the height. Sometimes they might give you the times symbol, or sometimes you just get the two letters together, because the two variables together means multiplication. And then all we do after that is identify which one is the base, and the base is 12. Which one is your height, and your height is 7 feet. And then we just multiply 12 times 7. And 12 times 7 gives me 84 feet square. So this is using your formula, and this is using the correct measurements. You gotta pick that you're using the height and you're using the base. And understand why we use the height, because the height is basically like the same thing as the width of the rectangle. And this is why it's so important that you know how to find the area of rectangle, because that information transfers to the parallelogram.